1.1 Green Theorem. So after this, we will learn about the Stokes Theorem and also a Gauss Theorem. So what is the Green Theorem? So in this Green Theorem, you will use the line integral and also a surface integral. So Green Theorem states the relationship between a line integral and the surface integral. So you will do a line integral, which is the single integral, and the surface integral, which is a double integral over a simply connected plane region R. For example, you have this plane, this R. Okay, simply connected region means it doesn't intersect itself. So this is another example for the simply connected region, okay, R. So you have this line C1, C2, and C3. And also this circle, region R, and this line C, okay, around a region counterclockwise. Okay, counterclockwise means positive orientation. Okay, counterclockwise, this one. You can see the arrow is pointed to the counterclockwise. So what is the definition of the Green's theorem? If C is a closed curve, okay, closed curve means it start and end at the same point with a counterclockwise orientation on plane XY. Okay, let F, okay, F is a function Pxy, Qxy, and P and Q have continuous first partial derivative. Then the Green's theorem is by this definition. Okay, so this is your left hand side and this is your right hand side. So you can see this is a line integral, okay, with the single integration, and this is your surface integral with this double integration. So this is the most important parts of this subtopic, how to solve the Green's theorem. This is the definition of Green's theorem. So you know the left hand side is the line integral with the single integration, and the right hand side is the double integral, okay, surface integration. Okay, so step number 1 is to sketch the region, okay, by looking at the information given in the question. So you can draw the region, whether it is a triangle or maybe a circle. Okay, first you have to sketch and understand all the information given in the question. And then step number 2, okay, you have to identify the question asks you to verify or to prove or just to evaluate. If the question asks you to verify or to prove, you have to calculate both sides, left hand side and also the right hand side. If the question just asks you to evaluate, you just calculate one side only. Okay, for example, this question, evaluate f dot dr. So you know this is the left hand side, f dot dr. So you need to calculate this right hand side. Okay, similarly, if the given in the question is the right hand side, so you have to calculate the left hand side. Example 1, prove Green's theorem for integration of x squared plus y squared dx plus x plus 2y dy. So you can see the keyword here is prove. Prove the Green's theorem. So prove or verify means you have to calculate both sides, left hand side and also the right hand side. Prove this, which has been evaluated by boundary that defined as x equal to 0, y equal to 0, and x squared plus y squared equal to 4 in the first quarter. So remember, step number 1 is to sketch your region or sketch your figure. Okay, so I have sketched the region here. So you have this x and y. Okay, x equal to 0 here and y equal to 0, and this is the line for x squared plus y squared equal to 4. Okay, actually, okay, this one, but you will get the full circle, but this line said in the first quarter, so just take the first quarter here. Let's collect all the information first. So this is the definition of green theorem, left hand side and the right hand side. So by looking at the question, you have to identify what is your P and what is your Q. So in this case, okay, you P dx Q dy. Okay, so dx, this is your P and this is your Q. P dx Q dy. So you get P is equal to x squared plus y squared. Del P del y, 2y. Del Q del x is equal to 1. Okay, we have to find this. Okay, so before you solve left hand side and the right hand side, just take out all the information. And you can see here the surface is a circle. So we use the plane polar coordinates. You have y here. So for a circle, y is equal to r sine theta. And dA is equal to r dr d theta. Okay, so now continue. Okay, let's solve for the right hand side. Okay, so this is the right hand side. Del Q del X minus del P del Y. This is del Q del X and this is your del P del Y. So 1 minus 2y. And your dA is equal to r dr d theta. Change to plane polar coordinates here. So your r, your radius for the circle is from 0 to 2. So you get the limit for r is from 0 to 2. And limit for theta is from 0 to pi over 2. Okay, this is limit for x 0 to 2. And limit for theta is 90 degree. So this is equal to pi over 2. This is how you get the limit. So now you want to solve this surface integral. Okay, simplify this. You get this value. Okay, so first you want to integrate with respect to r. Okay, integrate this with respect to r. So r you get r squared over 2. 2r squared you get 2r power of 3 over 3. Okay, next you have to substitute lower and upper limit for r. Okay, substitute correctly. And then integrate this with respect to theta. Okay, integrate 2, you get 2 theta. 16 over 3 sin theta, you get 16 over 3 cos theta. Then you need to substitute your lower and upper limit, then simplify. So this is your answer for the right hand side, your surface integral. So to prove your Green's theorem, you have to show that the right hand side is equal to the left hand side. So this is one side. You need to solve another side, which is the left hand side. Left hand side is the line integral. So this is your figure. I just copy it here. Okay, very small. So for line integral, you need to solve C1, C2, and C3. So let's solve for C1 first. Okay, so you can see C1, x is from 0 to 2, y equal to 0. So you get dy equal to 0. So how to solve this? Okay, p dx plus q dy. Okay, this is the formula for the left hand side. So this is your P and this is your Q. So you just substitute all this value. So your P, this is your P, x squared plus y squared, right? So you know y is equal to 0 for C1. Then just substitute 0 here. And then your Q is equal to x plus 2y. So x plus 2 times 0. And then dy is equal to 0. Okay, so you get 0 for all this part. So x is x squared dx from 0 to 2. Okay, just solve this line integral. So solve this x squared. Integrate x squared. You get x power of 3 over 3. From 0 to 2, you get 8 over 3. That is for C1. For C2, C2 is this line, okay, for the first quarter of the circle. So x is equal to 2 cos theta. y is equal to 2 sine theta, dx d theta is equal to negative 2 sine theta, and dy d theta 2 cos theta. Okay, again, this is your P and Q from the question. So you just substitute all this, your x squared, y squared, x and 2y into, okay, your x and y here, substitute into your function from the question. Okay, x squared plus y squared. So your x here 2 cos theta. So you will x squared, you get 4 cos squared theta. So this is your x squared, this is your y squared, and this is your dx, and this is your x, this is your 2y, and this is your dy. Okay, substitute all these and then simplify, you get this part. Okay, so now you need to solve all this integration. So I will separate it one by one. Okay, A, B, and C. Okay, let's solve this for each part. Okay, A, negative 8 sine theta d theta. Okay, you can solve it directly from 0 to pi over 2. So sine, integrate, you get cos. So you get 8 negative cos. So 8 cos theta. Cos pi over 2 is equal to negative 1. So for this part, A, you get negative 8. Okay, now let's solve part B and part C. Part B, 4 cos squared theta d theta. So take out your 4, put it outside, and cos squared theta, you can use this trigonometry identity. Okay, cos squared theta is equal to 1 plus cos 2 theta over 2. Substitute into this integration. So you can integrate this. 1, integrate, you get theta. Cos 2 theta, you get sine 2 theta over 2. 0 to pi over 2. Okay, substitute your lower and upper limit. Then you get pi for integration B. Here, this part. And now let's do C. Okay, C, you can do the integration by substitution. So U is equal to sine theta. U d theta is equal to cos theta. Okay, substitute all this. Then you get 8 U du. Integrate U, get U squared over 2. Substitute back what is the value of U. Sine squared theta over 2. Substitute lower and upper limit. 4 times 1. So part C you get 4. Okay, sum up all the answer for A, B, and C. So the integration part A, part B, and part C is equal to negative 8 plus pi plus 4. Simplify, you get pi minus 4. So this is answer for C2. Okay, remember you have C1, C2, and C3. So now let's solve C3. Okay, which part is C3? Okay, C3 is here. This line. Okay, so C3, y is from 2 to 0. X is equal to 0. So dx is equal to 0. Okay, substitute into the equation. So you get this value. Integrate 2y dy from 2 to 0. Then you'll get negative 4. Now you get all the answers for C1, C2, and C3. So your left hand side is C1, C2, and C3. So combine all the answer, 8 over 3, pi over 4, and negative 4. So this is your answer for the left hand side. So you can see here, left hand side, pi minus 16 over 3. And the right hand side just now, also pi minus 16 over 3. So you just prove your Green's theorem for this example 1. Example number 2, okay, verify Green's theorem. Okay, verify and prove. This means you have to show both sides, left hand side and right hand side. Again, integrate xy plus y squared dx plus x squared dy, where c is bounded by y is equal to x and y is equal to x squared. sketch the curve C. Okay, first step is to sketch your region or your figure. So we're given this line and also this curve. Start with the first line, C1 is this curve. Okay, y is equal to x squared. Okay, this is your C1 and this is your C2. Y is equal to x. Okay, so you get this curve and this line. Then you just put the arrow for the counterclockwise. Let's identify what is your P. Okay, so this is your P and this is your Q. P is equal to xy plus y squared and Q is equal to x squared. Okay, so now let's find your del P del Y and del Q del X. Okay, so del P del Y is equal to x plus 2y. Okay, just differentiate this with respect to y and differentiate q with respect to x, you get 2x. Okay, the right hand side. Okay, first do the right hand side. Identify your limit. Limit for x is from 0 to 1 and limits for y is from x squared to x. Okay, x squared to x. Okay, so similarly you have to substitute value of del q del x minus del p del y. So this is your del q del x, 2x, and del p del y, x plus 2y, x plus 2y. Integrate with respect to y first. So your x is from x squared plus x, your y is from x squared plus x, and your x is from 0 to 1. Integrate with respect to y, get this value, substitute your upper and lower limit, then you will get this answer. Okay, next is to integrate this with respect to x. Okay, very simple. So you get x power 5 over 5 minus x power of 4 over 4 with the limit 1 and 0. Substitute this, simplify, you get minus 1 over 20. Okay, so this is your right hand side, finish. Now let's move to your left hand side. Okay, so for left hand side, you have this line. Okay, line integral C1 and C2. So you want to solve for each line, C1 and C2. Okay, so for C1, y is equal to x squared. Okay, this curve. So your x is from 0 to 1. So from this, you get your dy dx is equal to 2x. So your dy is equal to 2x dx. To solve using this formula, p dx plus q dy. This is your p, this is your q. Then substitute your y here. Okay, y is equal to x squared. So x, y will become x squared. And y squared will become x squared squared. And dy here will become 2x dx. So you will get only x parameter, no more y in your equation here. Okay, all x parameter. After you get this, simplify this, then you can solve this integration. Okay, very simple. You get this value and this value, substitute the limit, simplify, then you get 19 over 20. Okay, this is only the C1. Okay, C1 19 over 20. Okay, C2 is for line y equal to x. So dy equal to dx. X is from 1 to 0. Okay, substitute into this given function from the question here. Okay, substitute your x equal to y. Okay, dy equal to dx. Simplify this. You'll get 3x squared. Then integrate 3x squared, you get 3x power of 3 over 3. Substitute the limit, then you will get negative 1. So combine answer for C1 and C2. 19 over 20 minus 1, you will get negative 1 over 20. This is your right hand side and this is your left hand side. So you just verify your
In example 2, you have 2 points of intersection. Okay, here 0, 0 and 1, 1. Okay, so now I will show you how do you get this point of intersection. Point 0, 0 and 1, 1. Okay, you have these two equations. Okay, one is this equation, y is equal to x squared, and another one is this line, y is equal to x. Okay, y equal to x and y equal to x squared. Okay, first you have to equate this equation. Okay, let's say I name it as equation 1 and equation 2. So equate this. Equation 1 is equal to equation 2. So this is equation 1. X is equal to x squared. And then just bring this to the left side and let it equal to 0. And then factorize it. And then solve this, we get x is equal to 0 and x is equal to 1. Okay, so now you have two values of x. Okay, then you can plug in this value into equation 1 or equation 2. So now I want to plug in into equation 1, y equal to x. So when x equal to 0, you will get y equal to 0. And when x equal to 1, you get y equal to 1. So you get the points of intersection 0, 0 and 1, 1.
So for example number 3, okay, by using Green's theorem, evaluate integration negative y dx plus x dy, where c is the circle x squared plus y squared is equal to 9. So remember, evaluate. So what you have to do, if the keyword is evaluate, okay, let's check again here. Okay, so you can just calculate one side only. Okay, verify and prove, you have to show both sides. Evaluate only one side. Step number 1 is to draw or sketch your region. Circle x squared plus y squared is equal to 9. So your r squared is equal to 9. So your r is equal to 3. Okay, so this is your figure. The circle with the counterclockwise with the radius 3. Given here is the left hand side. Okay, left hand side is the single integral, line integral. So you have to calculate the right hand side, double integral. Okay, so let's calculate double integral. This is your double integral. So given this equation, okay, from the question, so your P negative y, your Q is equal to x. So find del P del y is equal to negative 1 and del Q del x is equal to 1. Okay, so substitute these two into this equation for right hand side of Green's theorem. Okay, 1 minus 1, you will get 2. So this is a circle. You have to substitute the polar coordinate for circle. So you know x is r cos theta, y r sin theta, and ds r dr d theta. Okay, so you get 2 dA from this value. And your dA is equal to r dr d theta. So your r, limit for r is from 0 to 3. Okay, 0 to 3. And limit for theta is from 0 to 2 pi. Okay, full circle is equal to 2 pi 360 degree. So this is your double integral. Okay, solve this. Okay, 2 r dr d theta. Integrate this with respect to r. You get 2 r squared over 2. Okay, simplify this. Substitute r equal to 3. 3 squared is 9. 9 minus 0. So you just have to solve 9 d theta. 9 integrate respect to theta, we get 9 theta. Substitute 2 pi. So you get 18 pi. So this is your answer. So instead of using the line integral for the circle, okay, you can use the line integral. Okay, you also can use the double integral. So that's all for today. Thank you very much.